In this video, we're going to talk about prime factorization. So first, we're going to talk about prime numbers. A prime number is a number. We can look at some examples: 2, 3, 5, 7, 11, 13, and 17, 19, 23, and so on. And if you look at these numbers and say 2, the only number that can go into 2 are the only numbers that can go into 2 are 1 and 2. And the only numbers that can go into 3 are 1 and 3. And the only number that can go into 5 are 1 and 5, and the same for all the other numbers. So you cannot find any other number except 1 and itself, and that can go into that number. This kind of numbers are called prime numbers. But when we talk about prime numbers, first of all, this number has to be greater than 1. So for 1, we don't really consider it as a prime number, although this is still true because the only number that can go into 1 is 1 and 1. But we're not going to consider 1 as a prime number. There is a reason for that because when we do factoring, we don't really want to factor a number as 1 times itself when we do prime factoring. For example, you can write down, say, 4 as 1 times 4, and you can keep doing this forever. Say you can write down this 4 as another 1 times 4. So keeping this first one, and you write the 4 as another 1 times 4. You can keep doing this, but it really doesn't do anything except because any number times 1 would be self. So when we do factorization, when we break down number, we don't really want to break down this number as 1 times itself. So that's why we define a prime number cannot be 1. The former definition for prime number is a whole number greater than 1 and has no factors, or what you can call divisors, other than 1 and itself. Just like we explained here, as you can see, any number that can go into each of the numbers are 1 and itself. So any number that can go in there, we call factors or divisors. When we say go in there, we mean multiplication. So you can write, say, 5 as 1 times 5, and we call 1 a factor. We also call 5 a factor, or you can call them divisors. And this concept will be used over and over throughout algebra class. And a composite number is also a whole number greater than 1, that which is the same as the first condition. So you can see 1 is not a prime number. 1 is not a composite. So we just exclude 1 when we talk about prime and composite number. So a composite number is not prime. For example, we have, say, 4. 4 is not prime because I can break down 4 as 2 times 2, and you can see that that doesn't satisfy the condition because they said factors. You can only have factors 1 and itself. You cannot have any other factors. But we have a factor 2, which is not 1, which is not 4. Itself for 4 means 4. And so that's not a prime number. That's a composite number. So when we say, or you can say any number that can go into a prime number is 1 in itself. When we say go into, we call these numbers factors or divisors. And so as you can see, we can find a 2 that can go into 4, but it's not 1 and it's not 4 itself. And so that's why this is 4 is a composite number. So for a composite number, we would like to do what we call prime factorization. So which means you're going to break this number down to all the prime numbers. For example, 4 I can break down as 2 times 2, and as you can see, 2 is a prime number. So this is called a prime factorization. And we can look at another example. So we have a 6. I can break it down. When I say break down, I mean we can write it as a product of 2 numbers, and such that each of the number is prime. and 2 is prime, and 3 is prime. And so let's look at, so here are just two simple examples. Now we're going to look at, say, what if we want to break down 60 into all the prime numbers. We look at these two examples. The first one, we want to factor 60 into a product of prime numbers. And so we can use something called a factoring tree to help us do this kind of question. So what we do is we can start with the number 60, whatever the number given, and we can break 60 down. There are many ways you can do. For example, you can break down as 2 times 30. You can also say break 60 down as 6 times 10. There are many ways. But you have to continue. After you break down into these two numbers, you got to continue until every number is prime. As we can see in this case, 2 is prime. So let me circle this number. If it's prime, that means you can keep it, leave it. You don't have to do anything to that number. But 30 is not prime because we can continue to factor it as 2 times 15. And so 2 is prime, but 15 is not, because 15 can be factored as 3 times 5. And now every number we have is prime now. So we circle all of these numbers. And then we can write down our answer. So 60 equals the numbers we circled, 2 times 2 times 3 times 5. And we can also break down 60. If we, in the other ways, times, say we break down 60 as 6 times 10. If we do this, and 6 is not prime because we can break down 6 as 2 times 3. And now 2 is 3, and 2 is prime, 3 is prime. And 10 we can break down as 2 times 5, and both of them are prime. And we can see we have 2 times 3 times 2 times 5. So if you want to write your answer this way in any order, it's fine. But usually we like to keep a certain order so it looks more organized, and it's also easy for us to tell which numbers which prime numbers can go in there. So usually we start with the smallest, rearrange them in a non-decreasing order. So for example, we can switch this 2 and 3 to put the smallest first. So we will have exactly the same answer. So it doesn't matter which way you break down, you're always gonna get the same prime factors. And we can double check our answer so that if you have time, or you can use your calculator to do this. So what is 2 times 2 times 3 times 5? 2 times 2 is 4, and times 3 times 5, and 4 times 3 is 12, and 12 times 5 is 60. So which means this factoring is correct, and every number is prime. Now let's look at the next example. 160, we can do the same thing. We break down as, so for big numbers, it may not be very easy to see what times what equals 196. So here we have some rules that can help you to check what numbers can go in there. So the first rule, say we have 196, does 2 go in there? So we usually start with the first prime number 2. Say, does 2 go in there? Because we need to break down the number into all the prime numbers. So let's start with the smallest. And the rule is, if it's an even number, then 2 must go in there. And the even number is a number that ends in 0, 2, 4, 6, 8. Or you can say the last digit is one of these numbers. So the last digit is 6, it's even. If it's even, that means 2 goes in there. So we can break this down as 2 times, we can divide 196 by 2, we get 98. Now we can continue to check at it. As you can see, 98 is also even. So we can break down as 2 times 49, and 49 is apparently 7 times 7. So now all the numbers we have are prime now. So if any of them is not prime, you're going to have to continue to break it. Because it looks like a tree, that's why we call these factoring trees. And we using these trees can help us break down the number. But if you can do it without doing the factoring tree, that's also okay. So we can write down the answer 2 times 2 times 7 times 7. And so when we did this question, I didn't really say how do you know 60 is equal to 2 times 30. And if you didn't know, you can use the rules here, and because again it's even. That's why I know 2 must go in there. How do we know 3 goes into a number? This is something probably not everybody is familiar with. If you add all the digits of the number and it's divisible by 3, then we say this number is divisible by 3. So for example, 196, I know that 3 doesn't go in there because when I add all the digits, 1 plus 9 plus 6, I get 16. And 3 does not go into 16. If 3 doesn't go into 16, then 3 does not go into 196. So this is the rule. But if I change it to, say, 195, 3 must go into 195 because 1 plus 9 plus 5 equals 15. And 3 goes into 15, then 3 must go into 195. So this is a quick rule to help us check whether 3 goes into a number without doing division. And the other rule to determine whether a number is divisible by 5, it's similar to determine whether a number is divisible by 2. We just need to look at the last digit to see if the number ends in 0 or 5. And for example, 196, it doesn't end in 0 or 5, so 196 is not divisible by 5. But 60, it ends in 0. That means 60 is divisible by 5. And so when you factor 60, if you want, you can actually start with breaking down 60 as 5 times 12 and then continue from there. So to check, when you get a big number, it may not be easy to see what times what is equal to number. You can start with 2 and then 3 and 5 to check whether each of these can go into the number given. So the rule is if it ends in 0, 2, 4, 6, 8, 2 must go in there. So that's why we can break down as 2 times something. And if it ends in 0 or 5, 5 must go in there. So we can break down as 5 times 12. If adding the digits, say we add a 6 and a 0, 6 plus 0, we still get 6. And 3 goes into the sum, 6, then 3 must go in there. So another way to break down is you can break down as 3 times 20 and continue to break down to keep using the rules 2, 3, 5, 2, 3, 5. So that's so these rules will be very useful when you try to factor a number.